Hello guys, it's Gift. I'm back again with video 2 of the Simplify with Me. So here I have the first question. The first problem says I should simplify 27 to the exponent 2 over 3. So the same way we have done in video 1, the first thing that we are going to do, we are going to write 27 in a way that uh, it has a simpler, smaller base. So the first thing that we're going to do, you're going to switch on your calculator, press 27, equal sign, shift, fact. Then you get 3 to the exponent 3. Then where there is 27, you substitute 3 to the power 3. So it is going to be something like this. So from here, we have to apply a law of exponents, which it is represented in this way. Meaning that in our case, we are going to multiply 3 by 2 over 3. Then it is going to be 3 multiplied by 2 over 3. Then you can do it in many ways. Let's say 3 multiplied by 2 over 3. Then 3 times 2, it is 6 over 3. Then 6 over 3, it is 2. So this is going to be 3 to the exponent 2. Then 3 to the power 2, it is 9. So this is the simplified. So the steps are many because I want you to see how it works. So now let's move to the second one. So the second one, it is x plus 3 over x minus 3 times it is scary, but it's not really a big issue. So the first thing that we're going to do, we're going to factorize each and every expression that needs to be factorized. So this one does not need to be factorized. So we're just going to write it as it is. Then now this one has to be factorized, this one has to be factorized, this one has to be factorized, this one, it is fine like this. So now let's factorize this one first. So we see that this is a difference of 2 squares. So whenever you see a difference of 2 squares, you open and close a bracket, open and close a bracket. Then you're going to, this is x squared then you put x here, then another x comes here. So now with this 9, what are you going to do with it? You're going to put it under a square root. Then after putting it under a square root, you get 3. So you're going to say 3, 3. Then you can put positive here, negative here, or positive here, negative here. It depends on your liking. So now let's factorize the upper part. So the upper part, it is a difference of 2 cubes. So how do I know that 27 it is a cube? So 27 under a cube root gives us 3. So it is a cube. 27, it is a cube. That's how we know. So when you are factorizing a difference of 2 cubes, the first thing that you need to do, you open a small bracket, then open a bigger one. Then the small bracket, what you're going to do is that you're going to take x as it is, then here you put 3. You put 3. You put the 3. This one comes from here. And then also here you put x, here you put 3. But this side you have to square. You have to square them. Then here you put negative. Where did this negative come from? So it comes from here. So this negative, it is the same as this one. So now what you're going to do, what is going to be here, it is 3 times x, which is this 3 and this x. So it is going to be 3x. So now we have to deal with the signs. So in this, with difference of 2 cubes, here it is always positive. Here it is always positive. Then here, the sign that must be here must be the opposite of this one. So this one, it is negative. Then the opposite of negative, it is positive. So this is what we're going to have. But we need to punch this on a calculator. What do we get? We get 9. So here we're going to have this is what you're going to have divided by. So now we need to factorize let's check if x squared plus 3x plus 9 we can be able to factorize it. So to check if it can be factorized, this is the first thing you need to do. Then the second thing you need to do is to find the 2 numbers which when you multiply them, they give you 9, but when you subtract them, they give you 3. So do they exist? So yes, they do exist, but they are not whole numbers. So we are not going to factorize it. We're just going to leave it as it is. So here what we see is that this will cancel this. This will cancel this. They are not really cancelling, they are dividing. So after this, we are going to remain with x squared plus 3x plus 9 divided by x minus 3. Then this whole thing divided by x squared plus 3x plus 9 divided by x minus 3. So what you need to remember here, it is that when you divide fractions, for in case if you have x over y divided by z over k, you have to say x divided by 1 multiplied by the inverse of this. What is the inverse of this? So the denominator becomes the numerator, then the numerator becomes the denominator. So this is what happens. So this is what we are going to do. So this one, we just write it as it is divided by, then this one we flip it, the denominator becomes the numerator, then the numerator becomes the denominator. So here we can see that this is the same as this. So sorry, when the moment you flip, you must multiply. Sorry for making this mistake. Then we can also see that this is identical to this. So what does it mean? This will divide this, this will divide this, then we will remain with 1. So this is the answer that we are going to get. It is in 4 steps. 4 steps only. So I feel like I should elaborate more on why it is not factorizable, if I may say that. It is, we can factorize it, but we're not going to get whole numbers. You're not going to get whole numbers. So what you need to know about factorizing, it is that you open this, it is x and x. So you focus on 9 and 3. So we want numbers which, when we multiply them, they give us 9. But when we add them or subtract them, they give us 3. So we need to find the multiples of 9. So it is 1 times 3 times 3. So if, let's take 3 and 1. So if we multiply 3 by 1, we get 3. So 3 and 1 does not, it can apply. 3 and 3, they give us 9. But when we add them, they give us 6. Then when we subtract them, they give us 0. So hence, we cannot factorize this expression. So that's what you need to look at. So now let's move to the next problem. So the next one, it is so what I need to tell you about this one, it is that when you see more than one term on the denominator or on the numerator, or both, what you need to know is that there is a common factor that must be taken out. There must be a common factor that is taken out. But when it is in this way, can we be able to take out the common factor? No, we can't. We can't. What we need to do first is to expand. We need to expand this. We need to expand this. We need to expand this. We need to expand. This is fine. We need to expand this one, and this one. So how do we expand them? So it's a reverse. So we are moving from that law which says that when multiplying powers of the same base, we write the base, then we add the exponent. So now we are doing the reverse. We are moving backward. So we are going to expand it. So how do we expand it? So we have 3 to the power x plus 1. So if we go back, this was 3 to the power x multiplied by 3 to the power 1. So when we moved from here to here, we used the law which states that when multiplying powers of the same base, we write the base once, then we add the exponents. But now we have to move from here to here. So that's what we need to do. So here we're going to say 3. We're going to say 3 to the power x multiplied by 3 to the power 1 minus 3 to the power x multiplied by 3 to the power 2, all divided by 3 to the power x multiplied by 3 to the power 2 plus 3 to the power x. So now we can take a common factor in from the denominator and also from the numerator. So the common factor, it is 3 to the power x. As it appears in both the terms. So this one and this one. And you must note that we take out a common factor from an expression that has 2 or more terms. So for example, if we have 3 to the power x times 3 to the power x times 1, you can't say you're taking out the common factor here because we only have a single term. So that's what you need to keep in mind so that you don't make mistakes. So let's take out the common factor. When you take out the common factor, where there was the same common factor, we remain with 1. So it is going to be 1 times 3 to the power 1 minus 1 times 3 to the power 2. Then even in the denominator, you take out a common factor. Here you can see it. Where there was the common factor, we remain with 1, this one. So the common factors, they divide. So now we're going to say 1 times 3, it is 3, minus 1 times 3 exponent to the exponent 2, it is 9. Then now let's go below. So 1 times 3 to the exponent 2, it is 9 plus 1. Then the above part, punch it on a calculator, then you get negative 6 divided by 10. Then using your calculator, you get 3 over 5. This is the simplified question. So to prove if you have simplified without making mistakes, you have to let any number be x. You can say 1, then substitute 1 to the original x that you're given. So it is going to be 3 to the power 1 plus 1 minus 3 to the power 1 plus 2 divided by 3 to the power 1 plus 2 plus 3 to the power 1. Then you get negative 3 over 5. It shows that you have simplified correctly. So thank you guys. Please like, share, and subscribe for more.